I really hope that you are doing great. Welcome to today's class. It is our third lesson on a given mathematics topic, which is called indices. So it is a Form 2 mathematics topic. So today we are looking at further examples involving indices, and we are looking at question number 10, which is a past KCSE question done in the year 2001, paper 2, question number 2. So it is a question worth 3 marks. So we are told, solve for x in the equation 32 to the power of x minus 3 multiplied by 8 to the power of x plus 4 is equals to 64 divided by 2 to the power of x. So the first thing we're going to do is to break down these values to the smallest possible base. So you can see that 64, 2, 8 and 32 can all be expressed to a base of 2. Therefore, I'll look at the factors of 64. So I'll start with 2. So 64 divided by 2, you are going to get 32. Then 32 divided by 2, you are going to get 16. Then 16 divided by 2, you are going to get 8. Then 8 divided by 2, you are going to get positive 4. Then 2 into 4, 2 times. Then of course 2 into 2, 1. So this one simply means that if I take that one simply means that 64 can be expressed as 2 to the power of, so with 64 I have 1, 2, 3, 4, 5, 6. So 64 is the same as 2 to the power of 6. Then 32 is the same as 2 to the power of 5. 1, 2, 3, 4, 5. Then we also have 8 on the question. So 8 is the same as 2 to the power of 3. 1, 2, 3. Then I simply substitute the values in this particular question. So 32, I'll pick 2 to the power of 5. So this equation will be 2 to the power of 5, but it was 32 then to the power of x minus 3. Then from there we are multiplying with 8. So 8 is 2 to the power of 3. So this is 2 to the power of 3. Then into bracket, 8 was to the power of x plus 4. So this will be 3 into x plus 4. Then this will be equal to 64. 64 is 2 power 6. So this is 2 to the power of 6. Then we divide by 2 to the power of x. Then from the laws of indices, we know that whenever you multiply, you have to add the powers. Let me start by opening the powers or the brackets on the power. So this will be 2 to the power of 5 times x. We are going to get 5x. Then of course 5 times negative 3, we are going to get negative 15. Then multiplied by 2 to the power of 3x. Then 3 by 4, you are going to get positive 12. So this is equal to 2 to the power of 6, then divided by 2 to the power of x. So this can be rewritten as 2 to the power of, whenever you multiply, you add the powers. So this will be 5x, then minus 15. Then of course we add 3x, then plus 12. 3x plus 12. So this should be equal to, whenever you divide, you have to subtract the powers. So this will be 2 to the power of 6, then minus x. So we have like terms in this particular bracket. So let me add them. So this will be 2 to the power of, if you take 5x, then you add 3x, you are going to get 8x. So this will be 8x. Then negative 15 plus 12, you are going to get negative 3. So this will give you a negative 3. Then this will be equal to 2 to the power of 6 minus x. 6 minus x. Then after that, once you have one value to base 2, then also one value to base 2 on the left and right hand side of this particular equation, you simply drop the similar bases. Therefore you simply equate the powers. So if I equate the powers, I'm going to have 8x then minus 3 being equal to 6 minus x. Then of course after that, I'm also going to combine the like terms. So I'm going to have 8x. Then of course, if x moves to the left hand side, it will be a positive x. So this is equals to, on the other side I have a positive 6. If 3 moves to the right hand side, it becomes a positive 3. So this will give me 8x plus x. You are going to get 9x. So this is equal to 6 plus 3. You'll still get 9. Therefore, the value of x will be equal to 9 divided by 9. Therefore, x will actually be equal to 1. Then we look at our 11th example, which is also a past case question done in 2002, paper 2, question number 7. So it reads, solve for x in the equation 81 power 2x times 27 power x divided by 9 power x is equals to 729. So again, if you look at 9, 81, 27, and 729, all these numbers can be written to either a base of 3, I think to base 3. So let's start by looking at the factors of the largest possible given number, which is 729. So let me start by dividing through by 3. So if you take 729, then you divide by 3. 729 divided by 3, you are going to get 243. So this will give me 243. So I'm going to get 243. Then if you take 243 divided by 3, you are going to get 81. So this will be 81. Then if you take 81 divided by 3, you are going to get 27. You're going to get 27. Then of course 27 divided by 3, you are going to get 9. So this will be 9. Then 9 divided by 3, you are going to get 3. Then of course 3 into 3, you are going to get 1. Therefore 729 can be written as 3 to the power of 1, 2, 3, 4, 5, 6. So this is 3 to the power of 6. Then we also have 81. So 81 can be written as 3 to the power of 1, 2, 3, 4. So this is 3 power 4. We also have 27. So 27 is 3 to the power of 1, 2, 3. So 3 power 3. Then we have 9. 9 is the same as 3 to the power of 2. Therefore, if I substitute those values in this particular equation, I'm going to have, so 81 is 3 power 4. So this will be 3 to the power of 4. Then for 81, I also had 2x on the numerator. That is on the power value. So this will be 4 times 2x. Then multiplied by 27 is actually 3 power 3. So this will be 3 to the power of 3. Then for 27, I also had x on the power. So the 3 will multiply with the x. Then divided by 9 is actually 3 to the power of 2. So this will be 3 to the power of 2. Then I had an x on the power of 9. So this will be equal to 729 is actually 3 to the power of 6. Then if I apply the laws of indices, let me start by multiplying 4 by 2, which will give me 8x. So this is 3 to the power of 8x, then multiplied by 3 to the power of 3x, then divided by 3 to the power of 2x, then the whole of this is equals to 3 to the power of 6. So we have two ways in which we can deal with this. I can decide to multiply both sides by 3 to the power of 2x. So if I multiply this side by 3 to the power of 2x, I also multiply this side by 3 to the power of 2x. Of course, 3 power 2x and 3 power 2x on this side will cancel out. So I'm going to remain with 3 to the power of 8x, then multiplied by 3 to the power of 3x. Then this is equal to 3 to the power of 6, then multiplied by 3 to the power of 2x. Then of course after that I'm going to apply the laws of indices, that whenever you multiply you have to add the powers. So this will be 3 to the power of 8x, then plus 3x, which should be equal to, on the right hand side I have 3 to the power of 6 plus 2x. Once the bases are the same, you simply equate the powers. So this one means that 8x then plus 3x, this one should be equivalent to 6 plus 2x. Then 8 plus 3, you're actually going to get 11. So this is 11x is equals to 6 plus 2x. So this will be 11x then minus 2x will actually be equal to 6. Therefore 11 minus 2, you are going to get 9x, which is equal to 6. Therefore the value of x will be equal to 6 divided by 9. So if you simplify this by 3 will go here 2 times, then 3 into 9 3 times. So the value of x will actually be equal to 2/3. Then we look at our 12th example, which is also a past cases question done in 2005 paper 2 question number 1. So it reads, find the value of y in the equation 243 times 3 power 2 y divided by 729 by 3 power y, then divided by 3 to the power of 2y minus 1 is equals to 81. So similarly, I'm going to start by looking at the expressing these to base 3, because 81, 243 and 729 can all be written to a base of 3. So I'll pick the largest possible given value in this case, of course, which is 729. So if I divide through by 3, I'm going to get so if you take 729 divided by 3, you are going to get 243. So this is 243. Then I also divide through by 3. So 243 divided by 3, you are going to get 81. So this is 81. Then of course 81 divided by 3, you are going to get 27. Then 27 divided by 3, you are going to get 9. Then 9 divided by 3, you are going to get 3. Then 3 into 3, 1. So that means 729 can be expressed as 3 to the power of 1, 2, 3, 4, 5, 6. So this is 3 power 6. Then I also have 243 can be expressed as 2 to the power of 5. So 1, 2, 3, 4, 5. Then you also have 81. So 81 can be written as 2 to the power of, sorry, this should be 3. This should also be 3. 3 to the power of 5. Then this is 3 to the power of 1, 2, 3, 4. So this is 3 power 4. Then we also have on the question 243, 3, 3, 81. Yeah, those are the only values that we have on the question. So if I substitute 243 will be 3 to the power of 5. So I can rewrite this as 3 to the power of 5, which is our 243, then multiplied by 3 to the power of 2y, then divided by 729 is 3 power 6. So this is 3 to the power of 6, then multiplied by 3 to the power of y, then divided by 3 to the power of 2y, then minus 1, 2y minus 1. Then the whole thing is equals to 81, which is 3 to the power of 4. Then we can start applying the laws of indices. So the first thing I'm going to do, I'm going to apply a law here. I also apply a law on the numerator. So whenever you multiply, you have to add the powers. So on the numerator, I'm going to have 3 into 5, then plus 2y, because I'm simply adding those powers. So whenever you multiply, you are supposed to add the powers. When you multiply, you add the powers. Then divided by 3 to the power of 6, then multiplied by, when you divide, you subtract the powers. So this will be 3 into y, then minus into bracket 2y minus 1. Then this is equal to 3 to the power of 4. So this is going to give us 3 to the power of 5, then plus 2y, then the whole thing divided by 3 to the power of 6, then multiplied by 3 to the power of y, then negative times 2y, you are going to get a negative 2y, then negative times negative 1, you are going to get a positive 1. then this is equal to 3 to the power of 4. 3 to the power of 4. So this will be 3 to the power of 5, then plus 2y, then divided by 3 to the power of 6. Then remember that when you multiply, you are supposed to add the powers. So this will be 6, then I add these powers, so plus y, then minus 2y, then plus 1. Then the whole thing is equals to 3 to the power of 4. So this will give me 3. So this will be 3 to the power of 5, then plus 2y, then the whole thing divided by 3 to the power of, I can see we have like terms, so 6 plus 1, I'm going to get 7. Then y minus 2y, I'm going to get a negative y. Then the whole thing is equal to 3 to the power of 4. 3 to the power of 4. Then after that, I'm going to continue with the working. So I'm going to multiply both sides of this equation by 7 to the power of, that is 3 to the power of 7, then of course minus y. So let me make a line here so that I can proceed with the working. So I'm multiplying both sides by 3 to the power of 7 minus y. So this will be 3 to the power of 5, then plus 2y, then of course divided by 3 to the power of 7 minus y, then the whole thing is equals to 3 to the power of 4. So I multiply both sides with the denominator so that I eliminate the fractions. So I'll multiply by 3 to the power of 7 minus y. I also multiply this side by 3 to the power of 7 minus y. Of course these ones will cancel out, so that I remain with 3 to the power of 5, then plus 2y. This will give me this will be equal to, when you multiply you have to add the powers, so this will be 3 to the power of 4, then plus 7, then minus y. So this will be 3 to the power of 5, then plus 2y is equals to 3 to the power of 4 plus 7, you are going to get 11, then minus y. Then of course you drop the bases, so I'm going to remain with 5 plus 2y is equals to 11 minus y. On collecting the like terms, I'm going to get 3y being equal to 11 minus 5, you are going to get positive 6. So this will be positive 6. So it means that y is equals to 6 over 3, which is going to give us 2. So the value of y is actually 2. Then we look